Hi students, okay, in this lecture we will discussing the topic is applications of jet transform. So already finding in the previous lectures how to finding jet transform and inverse jet transform. So next one, applications. So where using the jet transform. So this is one of the technique, transform techniques to finding, that is to solve the equation of difference equations and to finding the solution of a difference equations. So what is the definition of difference equation, then how to finding the solution of the given difference equation by using jet transform. Okay now, so that is equal, first of all definition is, yes, an equation of the form, so yn plus k plus a1 into yn plus k minus 1 plus a2 yn plus k minus 2 plus up to so on ak into yn is equal to f of n, where a1 a2 up to so on ak are real constants and f of n is a function of n, is called difference equation of order k. So that means the equation involving the sequences. So yn plus 1, yn plus 2 up to so on yn plus k, that is all sequences. So what is the order here? Yn plus k is the kth order difference equation. So now solving this equation by using jet transform, then we getting the sequence yn, to finding yn here, to finding yn by applying jet transform and inverse jet transform. Okay na, so how to finding here in this one we will discussing. Okay, so now we have to find the solution of the above difference equation, that is to find the sequence yn by applying jet transform and inverse jet transform, also using shifting properties and given boundary conditions. Also given, without given boundary condition there is no using this method, and compulsory by using the boundary condition. If the given condition, then finding the solution. Okay, so this is the definition and procedure. See the example here. Yeah, first one, solve the difference equation yn plus 2 plus 4 yn plus 1 plus 3 yn is equal to 3 power n, with y0 is equal to 0, y1 is equal to 1. So this is a difference equation of second order. yn plus 1, last term yn plus 2, and that means the highest order is 2 and n plus k kada, k is equal to here. So this is a second order difference equation with given two conditions, that is two initial conditions, that is boundary condition y0 is equal to 0 and y1 is equal to 1, two conditions. So second order compulsory two conditions undali. Okay, so now here procedure, see that the given equation. So now applying jet transform on both sides. So taking jet transform of the both sides, so jet transform of yn plus 2 plus 4 into jet transform of yn plus 1 plus 3 into jet transform of yn is equal to jet transform of 3 power n. So jet transform of yn plus 2 means by using shifting property. Second shifting theorem andi, jet transform of un plus k form undi manaki. So ఆ ఫార్ములా అప్లై చేసుకోవాలి ఇక్కడ, సెకండ్ షిఫ్టింగ్ థియరమ్ ఆఫ్ జెడ్ ట్రాన్స్ఫార్మ్. సో దట్ ఈస్ ఈక్వల్ టు ఫార్ములా ఏంటి మనకి, జెడ్ స్క్వేర్ ఇంటూ ఎఫ్ ఆఫ్ జెడ్ మైనస్ వై నాట్ మైనస్ వై1 బై జెడ్. అక్కడ మనకి యూఎన్ ప్లస్ కే అంటే సీక్వెన్స్ యూఎన్, ఇక్కడ యూఎన్ ప్లేస్లో వైఎన్, అంటే యూ నాట్ ప్లేస్లో వై నాట్, యూ1 ప్లేస్లో వై1. ఓకేనా, జెడ్ స్క్వేర్ ఇంటూ ఎఫ్ ఆఫ్ జెడ్ మైనస్ వై నాట్ మైనస్ వై1 బై జెడ్ ప్లస్ 4 ఇంటూ, సో జెడ్ ట్రాన్స్ఫార్మ్ ఆఫ్ ఎన్ ప్లస్ కే yn plus 1, k is equal 1 కదా. సో z into f of z minus y0 plus 3 into, సో అజంప్షన్ z ట్రాన్స్ఫార్మ్ ఆఫ్ yn is equal to f of z, అంటే yn ప్లేస్లో un కదా, అంటే z ట్రాన్స్ఫార్మ్ ఆఫ్, ఆల్రెడీ we know that z ట్రాన్స్ఫార్మ్ ఆఫ్ un is equal to f of z. So that is equal to z ట్రాన్స్ఫార్మ్ ఆఫ్ yn is equal to f of z. So that is by using shifting theorem. So now substituting the given conditions, y0 is equal to 0, y1 is equal to 1. So z square into f of z minus y0 is equal to 0, y1 is equal to 1, 1 by z plus 4z into f of z minus y0 is equal to 0. So plus 3 into f of z is equal to z by z minus 3, అంటే ఇక్కడ 3 power n kada. So that is z by z minus 3. So now we have to common f of z common. So z square plus 4z plus 3 is equal to remaining term here z square by z kada, and minus z right outside plus z. Okay now. So where z transform yn is equal to f of z. So that is equal right outside. Yeah, this is a take the factors. So z plus 1 into z plus 3 into f of z is equal to, so take the LCM, z square minus 2z by z minus 3. So that is equal right outside, f of z is equal to z square minus 2z by z plus 1 into z plus 3 into z minus 3. So now this is f of z here. By using, we are applying inverse z transform. How to finding inverse z transform here? Inverse of f of z inverse of f of z kada. By using with method here, partial fraction method. So this is f of z. This is f of z is resolved to partial fractions. So what's the denominator here? All are real factors. And a by z plus 1 plus b by z plus 3 plus c by z minus 3. Now putting z on numerator. Z. Okay now. So now finding a value, b value, c value. So that is equal, already finding here minus 3 by 8 z by z plus 1 minus 5 by 12 z by z plus 3 plus 1 by 24 z by z minus 3 after finding a, b, c value. Okay now. Now applying z inverse on both sides. So that is equal, z inverse of f of z is equal to 3 by 8 into z inverse of z by z plus 1 minus 5 by 12 into z inverse of z by z plus 3 plus 1 by 24 into z inverse of z by z minus 3. That is equal directly by using the formula. Z inverse of f of z means sequence yn. Okay na. So yn is equal to 3 by 8 into minus 1 power n minus 5 by 12 into minus 3 power n plus 1 by 24 into 3 power n. So this is the required solution of the given difference equation. Okay. Yeah, second example here, solve un plus 2 plus un is equal to 2 with the given condition u0 is equal to 0, u1 is equal to 0. So that is equal to here given sequence. Now applying z inverse on both sides. So that is equal to z transform of un plus 2 plus z transform of un is equal to 2 into z transform of 1. So by using shifting property, so z of un plus 2 is equal to z square into f of z minus u0 minus u1 by z plus z of un is equal to f of z. So 2 into z of 1 is equal to z by z minus 1. So using the conditions, u0 is equal to 0, u1 is equal to 0. This is 0, this is 0. Okay. Z square into f of z minus 0 plus f of z. 2 into z by z minus 1. So take the common f of z common, z square plus 1 into f of z is equal to 2z by z minus 1. So therefore f of z is equal right outside to 2z by z minus 1 into z square plus 1. Okay na, which is converted to partial fractions. Then applying inverse z transform. So that is equal by using partial fractions. The first one is real factor. So that is a by z minus 1 plus this is z square plus 1 is imaginary. There is no real. So that is bz plus c by z square plus 1. Now putting in the numerator z. So you get z. Okay. Now finding a, b, c value here. A is equal to 1 we are getting. B is equal to minus 1. C is equal to minus 1. So that is z by z minus 1. Plus minus z square minus z by z plus 1 z square plus 1. So there is separating here. Now applying inverse z transform on both sides. So z inverse of f of z is equal to z inverse of z by z minus 1 minus z inverse of z square by z square plus 1 minus z inverse of z by z square plus 1. So that is equal, therefore z inverse of f of z is equal to sequence un. This is 1 minus this is cos n pi by 2 minus this is sin n pi by 2. Okay now. So this is the required solution of the given equation. Yeah. Next example here. Solve given sequence un plus 1 plus 1 by 4 into un is equal to 1 by 4 whole power n. So given condition. So only one condition means n plus 1 కదా, అంటే ఫస్ట్ ఆర్డర్ ఓన్లీ, ఫస్ట్ ఆర్డర్ డిఫరెన్స్ ఈక్వేషన్ ఓన్లీ వన్ కండిషన్. సో take the Z transform on both sides. So Z transform of un plus 1 is equal to 1 by 4 into Z transform of un is equal to Z transform of 1 by 4 whole power n. So by using shifting theorem, Z of f of z minus u naught plus 1 by 4 f of z is equal to, this is Z transform of a power n కదా, అంటే z by z minus a. So z into f of z u naught is equal to 0 plus 1 by 4 f of z into is equal to z by z minus 1 by 4. So take the common f of z plus 1 by 4 into f of z is equal to z by z minus 1 by 4, so which is right outside. F of z is equal to z by z minus 1 by 4 into z plus 1 by 4. By using partial fractions, which is converted to partial fraction, 2 into z by z minus 1 by 4 minus z by z plus 1 by 4. Now applying z inverse on both sides. So z inverse of f of z is equal to 2 into z inverse of z by z minus 1 by 4 minus z inverse of z by z plus 1 by 4, that is equal to the which is equal to sequence un. So 2 into which is equal to z by z minus a and a power n, the 1 by 4 whole power n minus this is minus 1 by 4 whole power n. So this is the required general solution of given equation. So this is a solving difference equation by using Z transform and inverse Z transform. Okay, for more videos please do subscribe my channel, like and share it. Thank you.